Seamus wants to measure the height of a small tree which is located on horizontal ground. He stands at a distance of 10.35 meters from the tree and using a clinometer calculates that the angle of elevation of the top of the tree is 27.5 degrees. His eye level is 1.8 meters above the ground. So this is Seamus. He stands at a distance of 10.35 meters from the tree. So this is the tree, and he's 10.35 meters away. The angle of elevation of the top of the tree is 27.5 degrees. So from his eye level, the angle of elevation is 27.5 degrees to the top of the tree. And his eye level is 1.8 meters above the ground. So his eye level is 1.8 meters. Part 1, calculate to 2 decimal places the height of the tree. Just need to find the height of the tree. In part 2, if Seamus decides to lie on the ground so that his eye level is at a height of 0.3 meters above the ground, determine what angle of elevation he would get for the top of the tree. Give your answer in degrees correct to 2 decimal places. So part 1, we're going to calculate the height of the tree. So I've drawn it out separately here. It's our right angle triangle. So remember we have 1.8, 27.5 degrees, 10.35. So we're going to let x be the height of the tree above Seamus's eye level. So from the top of the tree down as far as Seamus's eye level, we're going to call this x. Then, using TOA from our SOHCAHTOA formula, which we can only use with right angle formulas, we're going to have opposite divided by adjacent, which is going to be tan of 27.5 degrees. So TOA stands for tan equals opposite over adjacent. So if this is the angle, then this is the side that's opposite it. So x gets labelled as O. And then this is the hypotenuse, which we don't need. So this side here must be the adjacent 10.35. So the opposite we swap for x. And the adjacent we swap for 10.35. And this again is all equal to tan of 27.5 degrees. So then we want to just solve for x, so we're going to multiply across by 10.35. So get 10.35 times tan 27.5. Make sure the 10.35 comes first, and that gives us 5.39. So x is equal to 5.39. So the top of the tree to Seamus's eye level is 5.39. So then we have to add on the height of Seamus up as far as his eye level, which was 1.8. So x plus 1.8 is going to be 5.39 plus 1.8, which is going to be 7.19. So the height of the tree is 7.19 meters. So part 2. If Seamus decides to lie on the ground so that his eye level is at a height of 0.3 meters above the ground, determine what angle of elevation he would get for the top of the tree. Give your answer in degrees correct to 2 decimal places. So we're looking for the angle of elevation. So again, I've drawn out the diagram separately. So we have a right angle triangle. So we're going to let A be the angle of elevation from a height of 0.3 meters above the ground. So we have a height of 0.3 meters. And this is our angle of elevation that we're trying to figure out, angle A. We are still 10.35 meters from the tree. Then the height of the tree above eye level is going to be 7.19, which we got from part 1, minus the 0.3, which is the new eye level, which gives us 6.89. So 7.19 minus the 0.3 leaves us with 6.89. So from the height of the tree to the eye level is 6.89. Thus, we're going to use TOA, so tan equals opposite over adjacent. So tan of A is going to be opposite over adjacent. The opposite is 6.89, so 6.89 is our numerator. The adjacent is 10.35, so our denominator is 10.35. And 6.89 divided by 10.35 is 0.6657 to 4 decimal places. We should always round to 4 decimal places in the middle of a sum. We should never round off any smaller than that because we'll have an error in our answer. So if tan of A is 0.6657, then we're going to use the inverse function, because we use inverse when we do not know the angle, and we do not know what the angle is. That's what we're looking for. So A is going to be tan to the power minus 1, or the inverse function of tan, times 0.6657, and that's going to give us 33.65 degrees to 2 decimal places.